Hello everyone, and welcome to this F5 Distributed Cloud demo using multi-cloud networking. In this demo, I'll show you how you can use the multi-cloud transit capability using the F5 Distributed Cloud Global Network to, one, deploy a site in AWS and also in Azure, and then attach that site to a legacy or existing service and VPC running in those different sites. I'll show you how F5 provides simplified access to manage those services deployed across the clouds, to be able to see it, and ultimately how to take control and manage that. In this topology, I have 3 sites deployed. 2 are in AWS and 1 in Azure. And in this demo, I will specifically be deploying a Transit Gateway attached VPC using the F5 Distributed Cloud and an Azure VNET, and I'll be connecting these to my existing services in the respective clouds. Kicking things off, we log into the Distributed Cloud console and go to Shared Configuration. Go under Virtual Sites and then add a virtual site. Give it a name. Enter the site type as CE. And the important part here is we're going to be using a site label to identify what sites belong to this cluster. In this case, we're creating a generic label called site group with the value of group sites. And I'll be using this in each of the 2 sites that I deploy. Now we'll go under the Cloud and Edge sites. And specifically, we're going to create a virtual network. Now, this is a global network that we'll be using to connect our different sites that we deploy. Give the site a name. The type is global network. And that's all we need to do here to create the entity for the global network to span the different sites. Next, we'll be deploying the site with a label to associate the site with the global network. So here we'll give the site a name, and importantly, we're giving this a label. This label determines what sites belong to the site mesh group in order to participate in the global network. Choose the site region. We're going to choose creating a new VPC here. You could also use an existing VPC. We're going to use a new transit gateway, provide login access for debugging, and then we're going to choose here what availability zones our different networks belong to. In this case, I'm using US West 2A, and I'm going to enable a third subnet here for the inside network. And this is important in order to connect to my existing VPC, which is only addressed internally. The final part here is to choose which AWS credentials that we'll use to deploy the services within AWS, and we would need to have that pre-configured. The final step is to choose which VPC we want to attach to the transit gateway that we're creating in the new VPC within AWS. And the final part here is to choose which global network this site mesh will connect to. In this case, we'll just select the site's global network. And that's really all that you need to do in the Cloud Console in order to deploy a new VPC, add it to a site mesh group, and connect it to the global network. While that's going, once the configuration is configured, we can then go to Plan and apply the configuration to kick off that deployment. And while that's happening, we can now start our deployment in Azure. Go to Azure and then add a VNet site, give that site a name, and importantly, to participate in the site mesh group, we need to add the associated label for the site. Next, we're going to choose a resource group that belongs in Azure that we want to name it to, and it's unique. And this is where the F5 Distributed Cloud configuration will be created. We need to give it a new CIDR block. And in this case, we're choosing to use 2 interfaces for the deployment. One is to support external traffic north-south, and one is to route traffic internally east-west for our distributed application. Next, we give the CIDR blocks, and finally, we choose that this site should participate in the specific global network that we just created in the step earlier. The final step here is to apply, save and exit after choosing our credentials for Azure specifically. Enter in any debugging information like the SSH key will help you debug later if you need to. Don't forget to do that, as is simple to deploy again, but it's nice to have available without having to do that. Once the configuration is provisioned, you can go ahead and click Apply to kick that off and create the services within Azure. Once everything is complete, you can go under Networking, Site Mesh Groups, and now we're going to create the group of all the sites that we added the labels for. We're going to choose a site mesh group of type full mesh, and in this case, we're going to say it must be a virtual site. So what this does is it allows all of our sites to have direct access to one another. And we can see this by navigating to Site Connectivity, Site Mesh Group, and we can look at our site's mesh. Now notice here that one of the tunnels is down. That's because those sites are still being provisioned. Once provisioning has completed, you can look at the status page and go to Terraform parameters for additional information, should you have any provisioning errors, or if you just want to know what resources are used in the creation of those services by the Distributed Cloud Console. Once you log in and look at your console, you should be able to see the list of services that are running fairly easy, and they're fairly simple to identify. Here I'm showing that a route on the services VPC was created by the Distributed Cloud Console, and this is in order to reach other services running within my network. If you need to make any changes, such as linking or creating a route from the existing VPC that I linked my new VPC to, then I would go under the route table, and you can see here that the existing route that I had in that VPC is not currently valid, and that's because I deployed the new VPC after this VPC was created. So in order to use the new transit gateway created by the Distributed Cloud, we simply need to update those next hops in the route table. And once that's done, we should now see valid routing status. In order to reach that, then we'll go over to the Azure side and take a look at the resources that were just provisioned by the Distributed Cloud Console. If we take a look at the master node, this is the master CE node that was deployed, we can see that there are two interfaces, one for the outside and one for the inside interface. And in this case, we can see that the inside interface has a private IP address and no public IP. In order to make the internal network reachable, this is the internal network that I will be attaching through VNet peering to the distributed cloud, we'll need to go to the routing table specific for the internal network, remove the existing route that was created by the Distributed Cloud Console, and replace it with one that will be appropriate for your next hop for the CIDR block. In this case, my internal network, so what I'm doing here first is I'm creating a generic route to say that all traffic should go to the CE node internal interface. So if I don't know what it is, we can route it or send it over the Distributed Cloud network. The next part is to go back, and now we'll take a look at the peering. And now what we're doing is we're going to establish peering between the newly created VNet with my existing VNet where my application server runs. The peering is fairly straightforward. Put in your two network names and resource groups, and that should be all that's needed. Azure takes care of routing between the two different VNets. So now back on the Distributed Cloud Console, we take a look at our Azure VNet. We can see that the static routes is empty, and in order to reach our legacy peered network, we need to take care of that and advertise that across the global network. In order to do that, we have the CIDR block for our former legacy VNet that we just did or established routing with the VNet peering. And what this does is it allows the Distributed Cloud to announce the CIDR block belonging to that internal VNet across the global network. We need to add a couple attributes to make this happen. One is install host OS and install forwarding. You do not need to do the rest, but advertise doesn't hurt in case you're using other routing protocols. With that custom route in place, go ahead and click Apply, and finally you're ready to save your settings. And now this announces the new network across the global network. So now, if we take our private IP address for our app server running in our legacy VNet on Azure, we will now be able to ping it from our monitoring VPC subnet that we attached, the TGW subnet, which Distributed Cloud created, provisioned, using the Distributed Cloud Console. And we can see here that we have routing across all the sites in our Distributed Cloud. And that's it in a nutshell. Thanks for watching, and be sure to check out more of our Distributed Cloud videos at f5.com, distributed cloud, and you can search for that in YouTube. Again, thanks for watching.